Hello friends, let us today study modified fats. First of all, let us see why do we need modification of oils and fats. In fact, the oils and fats, when they are extracted from various sources after refining etc., they may not be present in their desired form, in their desired functionality to suit a specific food operation or a specific use. So, these fats and oils are usually modified using appropriate procedures in order to improve their functional properties like crystallization, melting behavior and other properties, so as to make them suitable for specific operations or for specific use. Okay. So, by modifying the fat, we actually modify or alter their physical properties, we improve their stability, as well as we do these things to achieve economical benefits out of, or maximum economical benefits out of these fats and oils. So, commonly used methods for modifications of oils and fats include hydrogenation, interesterification and winterization. So, we will see one by one about these operations. So, first of all, let us study hydrogenation. So, hydrogenation actually is a heterogeneous reaction process which is complex in nature and where that is the different reactions occur between hydrogen, which is gaseous phase, and unsaturated fatty acids, that is the liquid phase. And these reactions between the gaseous phase and the liquid phase convert either all of or some of the unsaturated fatty acids into saturated fatty acid. You can see in these diagrams here, that is the unsaturated fatty acid. In the earlier class, we have seen that the carbon has, that is the valency of the carbon is not saturated. There will be 2 or 3 or more than that, or one double bond in the chain of the fatty acid. So, here in the hydrogenation process, these double bonds or unsaturation is converted into saturation. So, obviously, by the introduction of hydrogen into the molecule under suitable or appropriate conditions. So, you see here this double bond is with the, by addition of hydrogen in the presence of nickel is converted into a single bond. So, the unsaturated vegetable oil or that is unsaturated fatty acid is converted into a saturated fat or a saturated vegetable fat or ghee, and the same thing here is shown in the case of molecular formula. So, that is a linolenic acid is it has about 3 poly, that is double bonds, okay, in its structure. So, if this linolenic acid is saturated, once one double bond is saturated, it will be converted into linoleic acid. If the linolenic acid is desaturated or its one double bond is converted into single bond or saturated bond, it will be converted into oleic acid, and the oleic acid after saturation will be converted into stearic acid. So, in this process unsaturated oil or unsaturated fat is converted into a saturated fat or saturated oil. So, in fact, the hydrogenation process involves multiple physical and chemical reactions like mixing and dispersion of the catalyst by a mechanical mixer, diffusion of hydrogen gas through the mass of oil to the catalyst surface, adsorption of the reactants which are hydrogen and unsaturated fatty acids on the catalyst surface, and partial or complete saturation of the unsaturated fatty acid on the catalyst surface, and then desorption of the products of the reaction like saturated fatty acids and some of the unsaturated fatty acids or oils etc., or oil molecule from the catalyst surface, and finally, release of heat due to the exothermic nature of the hydrogenation reaction. So, these are the different stages or different reactions which take place during the hydrogenation process. The same thing has been shown here in this diagram pictorially. Okay. So, as I already told you, the purpose of hydrogenation is actually to change naturally occurring fats and oils into physical forms with the consistency and handling characteristics required for the desired functionality, as well as another important function is to improve its oxidative stability, because unsaturated fats and oils generally are more prone to oxidation. So, by converting unsaturated oils into saturated fat, we are making them actually more stable to oxidation, that is the oxidation will be prevented. So, obviously, the effect of hydrogenation include unsaturated fatty acids become more saturated, iodine number or iodine value of the oil reduces, because iodine value is the measure of the degree of unsaturation. So, more the unsaturated fat, higher will be the iodine value. So, here in the hydrogenation process we are making more saturated fat. So, iodine value of the oil generally reduces, melting point of the oil increases, the oxidative stability of the oil improves, and at the same time during the hydrogenation process a multitude of side reactions take place, including the formation of certain alcohols and acids, and some polymerization or some isomerization of some of the polyunsaturated fatty acids may also take place. Though the products of hydrogenations are a very complex mixture because of the simultaneous reactions that occur in the system depending upon the temperature, pressure, catalyst and all those things. So, the saturation of double bonds, cis trans isomerization of the double bond and shift of double bond locations usually to the lower energy conjugated sites. So, these different things take place. Here in this slide again we have shown a hydrogenation system in the process, that is the equipment. It is basically a reaction vessel hydrogenator. So, in that reaction vessel it is equipped with all sorts of all necessary instrumentation and other accessory facilities for making the reaction to take place, that is the for addition of the hydrogen and then providing suitable temperature and pressure and the for system for catalyst additions, that things too. So, you can the hydrogenator batch hydrogenator system, in fact it has or it is provided with a mechanical agitator, heating and cooling arrangement or assembly, that is hydrogen gas asperger. You can see here in this hydrogen gas inlet, then temperature controller, pressure controllers, vent valve for the spent gases, safety rupture disc or agitator seal protector, rupture disc to protect the reactor against over pressurizing, or hydrogen gas flow meter with flow indicator, gas flow totalizer and vacuum ejector or vacuum pump. Sorry. So, the hydrogenator is provided with all these necessary arrangements for making the reaction proceed in the desired conditions. As far as the process is concerned, that is conducting the hydrogenation process, that is the equipment first of all, that is the filled to its desired capacity, all right. That is the aisle. First it is heated to around 85 to 95 degrees Celsius for 15 to 20 minutes, and then through the input assembly the aisle is introduced into the reaction vessel, and then fresh catalyst nickel is added at a rate of maybe 0.01 to 0.0% on the weight of the aisle basis into the reactor, when the aisle temperature has been reached to around 155 to 160 degrees Celsius. In fact, the reaction vessel is provided all sort of heating, cooling and other arrangement you have seen in the earlier slide. So, the hydrogenation reaction then proceeds, heat generated from the reaction raises the aisle temperature in the reactor, and then this hydrogen supply or maybe steam supply automatically cut off when this temperature comes to the desired level. The reaction in a batch reactor is carried out either adiabatically or isothermally. In the continuous hydrogenation process, in fact, different maybe it can be considered as a different batch equipment arranged in parallel together. Maybe here in this system you can see 3 such reactor vessels are arranged in parallel, and all these vessels are provided with the suitable arrangement for the continuous inflow of the feeding of the aisle in the first system, maybe the a mixture of the catalyst, aisle and hydrogen gas catalyst and aisle is fed into the reaction vessels, and then hydrogen gas is introduced, right, and then from the in the first vessel it is given some time, then from the first vessel again it passes through the second vessel and then goes to the third vessel, and in the each vessel required temperature and pressure etc. is maintained, and finally, when it comes to the last vessel, that is after the this hydrogenation process is complete, the product is taken out, it is this sent to the filtration unit for the removal of the catalyst, added catalyst from the mixture, and then oil or fat, saturated fat is allowed to cool down to solidify. And in fact, that is the removal of the catalyst is very important, and the filter which is provided in the system, it should be perfect to remove as maximum, in fact almost all the catalyst present from the aisle. Otherwise, it will have or it will give problems if the catalyst is remaining in the solid fat, it will be problematic. So, all the catalyst has to be removed. Regarding the catalyst, it is then once after the reaction, its effectiveness can be little bit reduced. So, it can be further activated, and a catalyst can be used at 3 or 4 times the same catalyst, because in the catalyst actually it is not, it is just activating the reaction, it is not getting changed or it is not getting modified, only maybe that its effectiveness may get reduced. So, it may be further activated. The end of the saturation process, both in the continuous process as well as in the batch process, is determined by doing certain tests. In fact, both the systems are provided by taking out the sample, and these samples at regular intervals are taken out and they are analyzed for different tests like iodine value, refractive index etc. to know, and by these iodine value and refractive index, generally we find out that yes, the desired level of saturation, whether it has been reached or not, and once the desired level of saturation is reached, the system. All the hydrogenator equipments, they are provided at the top, some vent up valve etc. so that head space gases etc. which are generated during the reaction, they should be allowed at a continuous interval to go out of the system to maintain the proper reaction rate, etc. All right. So, this is the hydrogenation process in brief, and there are certain points to be considered, like process variables of the hydrogenation process. The important variable I told you is the pressure, and at low pressures the hydrogen gas dissolves in the oil. Okay. It does not cover the catalyst surface, while at a high pressure hydrogen is readily available for saturation of the double bonds. So, the increased saturation rate results in a decrease in trans isomer. Okay. So, this trans isomer development, that is the one important. So, accordingly the pressure and temperature and these combinations should be selected in such a way, so that as far as that low trans, that is the trans isomer formation is there. That is one of the major drawbacks, that is when these oils, etc. earlier class we saw that when they are heated, that the cis forms of the fatty acids is converted into the trans form. So, that may be one problem. So, by that is the increased hydrogen pressure, they are helpful in reducing the trans fatty acid formation. So, of course, however, this should be properly controlled. The temperature is another factor. The reaction increases substantially with the increasing temperature. So, hydrogen atoms near the absorbed double bond will react faster with the double bond. So, under these conditions the reaction interface is virtually instantly depleted of hydrogen. So, therefore, with increasing temperature the supply of hydrogen towards the catalyst reaction surface will eventually be the limiting factor for the reaction. So, that should be taken care of, as the isomerization reaction has a lower order dependency on the hydrogen than the hydrogenation reaction. Increasing temperature will boost the selectivity, but also the transformation. So, a proper balance between the balance between the temperature and pressure and other even catalyst type suitable selection of the catalyst, etc. should be maintained in the reaction system, so that we can get the desired selectivity and you can get the saturated fatty acids with the desired characteristics, but minimum or no transformation. The catalyst, I already told that the catalyst is in the hydrogenation is the reduced nickel, okay, and this nickel is supported on natural earth, and the high porosity permits the swift mass transfer from the and to the bulk phase, and the nickel powder of about 2 to 12 micron mean particle size is commonly formulated in the solid droplet to hard fat such as palm stearine or fully hydrogenated oil, because this nickel actually is a highly pyrophobic material. So, it violently burns it if it comes in direct contact with air. So, generally nickel is kept in some dissolved in some sort of oil to stop its direct contact with air. So, they normally in the plant the oil which need to be hydrogenated in the similar type of oil or in some hydrogenated fat, etc. it is kept. So, the nickel catalyst and oil, that is in a suitable proportion, is a mix preheated and then it is sent to the, but a good catalyst selection can help steer a reaction towards more or less transformation. So, that is important, that is in fact because the proper activity of the catalyst will facilitate the proper reaction at a proper rate, and which may encourage less conversion of cis into trans, but so it needs to be properly. Now, let us see what is the selectivity. In fact, this selectivity is a very important aspect in the hydrogenation of fat. By having appropriate selectivity, by properly considering having the or choosing the process parameter etc., we can get the hydrogenated fat or saturated fat of desired consistency. Okay, that becomes very. So, in fact, this selectivity is defined at under the normal conditions, that is highly unsaturated fat like polyunsaturated fat, they undergo conversion into saturated fat at a high rate than those with the this less unsaturated fatty acid. There is more polyunsaturated fatty acid hydrogenate at a faster rate than less polyunsaturated fatty acid, and that is the selectivity. In fact, in the triglyceride, linolenic, linoleic and oleic acid, because they have different unsaturation level. So, they get hydrogenated at different rates, and that can be seen in a simplified reaction model here. That is, if the rate of hydrogenation of linolenic to linoleic, if we say that K 1, that is the rate of conversion from linoleic to oleic be K 2, and rate of conversion of oleic to stearic if it is K 3, then linolenic selectivity SL 1 will be equal to K 1 by K 2, K 1 by K 2, that is the conversion of linolenic to linoleic and finally linoleic to oleic, and the linoleic selectivity will be SL 2 will be K 2 by K 3. However, in this model the concentration of hydrogen at the surface of catalyst is not considered. So, the rate constant will thus be influenced not only by the temperature and catalyst, but also by the process parameters which influence the concentration of hydrogen at the catalyst surface. So, by having proper selectivity or appropriate selectivity, we can get the fat or saturated fat of desired consistency for desired operations, that is more or less soft fat with having proper functional characteristics. So, the hydrogenation process, in fact, it is a important process for the industries. As I told you, that is the industry needs that the proper stability in the IL or the proper functionality in the IL, because the low that the IL with having higher unsaturated fatty acids are more unstable. Okay, they lead to rancidity development, they are very short life. So, these problems are some of these problems are solved by this hydrogenation process. In fact, the fully or partially hydrogenated ILs, they give better texture to the product. In fact, partially hydrogenated IL like soft fats etc., soft solid fat, they give better texture for products like cracker, cookies etc. They extend shelf life of both the IL as well as products containing that IL. They are easier to manipulate during the food processing operations and help move or help remove saturated fats from many products. So, this was about hydrogenation and its benefit and how it is done. Let us see another important process or method for modification of the fat, that is the interesterification. And this interesterification refers to the fat and IL reaction in which the fatty acids of triglyceride exchange positions from one triglyceride to another, thereby altering the chemical composition as well as physical properties of the fat. The efficient way for changing the controlling and melting properties of the oils and fat. Okay. This is one of the better way, that is enterification is a good process for controlling the melting properties of the oils and fat. The rearrangement process which does not change the degree of unsaturation or the isomeric state of the fatty acids, because they are simply changed from one place to other place. There is no change in the unsaturation, etc. Under some conditions, the fatty acids are distributed in a more random manner than they were present originally. So, based on the catalyst which is used for this interesterification reaction, the method is divided into two, like chemical interesterification and enzymatic interesterification process. In the chemical esterification process, in fact, you can see here in the figure, in this figure you see that here in the triglyceride, in the first position is the R1, second position is the R2 and third position is the R3. So, by this appropriate selection of catalyst and having the proper conditions in the reaction vessel, that is these properties, that is they can be interchanged, that is by there is another molecule. So, there you see here in this the R2 which was in the second position here, and here it comes to the first position, the R3. So, that is it is basically the interchange between the fatty acids group, maybe intermolecular. So, of course, the interesterification, it changes the overall melting profile, improves the compatibility, improves the plasticity and other characteristics. It combines the properties of mixed oils and fat. It can also be used to produce a waxy translucent fat for coating purposes. It blends a soft oil with hard fat, and by combining interesterification with other modification processes, many products such as shortenings, margarine, vegetable ghee with low trans fat or no trans fats, etc., can be formulated, and they give products of good satisfactory quality for confectionery and bakery usage. So, in the chemical transformation process, chemical interesterification, actually different chemical catalysts are used to facilitate the process. The catalysts, they depending upon their nature and their type and their reactions they catalyze, and under the condition under which they catalyze these reactions, they can be grouped into two categories, that is high temperature catalyst and low temperature catalyst. The high temperature catalyst include metal salts such as chloride, carbonates, oxide, nitrates and acetates of zinc, lead, iron, tin, cobalt, etc. Low temperature catalysts include alkylates of sodium and or sodium or potassium alloys. The alkylates of sodium are simple to use and they are inexpensive to use. Only small quantities are required and they are active at low temperature, that is at less than 50 degrees Celsius. So, in the interesterification process, that is again like any other food process, that is the quality of the product at the end should be controlled by controlling the oil quality, that is oil quality should be free from any contaminants, it should be free from moisture, it should be as low as possible in FFA content. This free fatty acid content will also deactivate the catalyst. So, it should be less in free fatty acid content. Also the oxidation parameters such as the peroxide value, etc., will lower the catalyst efficiency. So, the oil should be fresh, it should not be a rancid oil. Similarly, the type of the nature of the catalyst, that is the pure alkali metals such as sodium or potassium, where the ideal for such reactions and in small scale operations, these prove to be successful or very successful. The applied concentrations of the catalyst generally range in between 0.05 to 1.5%. This the setup here it shows that the how in the industry what are the different movement of the materials etc. Actually, you can see here this is the actual reaction system, which is again like a hydrogenated reactor. Here also this reactor is provided with all necessary instrumentation and other facilities to maintain the temperature, to maintain the pressure and to facilitate the entry of that is the IL, the catalyst and other, even in the same reactor that is the facility in the plant, because of the continuous nature of the plant they are provided with this deacidification facility, that is a deiodorization facility or bleaching facilities, all these things. So, bleached and neutralized iron is put to the reaction vessel where the catalyst is sent, and then the proper temperature, pressure and other conditions are maintained in the vessel to get the desired reaction or interesterification reaction process. So, another is the enzymatic interesterification, and here in fact, this in biologically derived enzyme, mostly the lipase or such other enzymes are used to facilitate. In the earlier case it was the chemical catalyst, here it is the enzyme is used as a catalyst. They are considered better because they have lower capital investment cost as compared to the chemical process. Even different varieties of lipases are used in industries because of their regio specificity and stereo specificity in the production of a specific structure. The enzymes may be non-specific or may be specific enzyme. Non-specific enzymes are used for the production of commodities fat to modify the overall melting properties, increasing compatibility within the solid phase and enhancing the plasticity of the final product, whereas the specific enzymes are used to produce tailor made products such as cocoa butter equivalent, anti-bloom agents, breast milk substitute, low calorie fats and so on. This is the reaction setup which shows that it is in, taken from the literature. That is a reaction vessel. Here actually that is this IL feed tank, that is pre-treated IL, neutralized and refined IL is passed through these packed bed reactors. These packed bed reactors, here in these reactors about 10 kg of the enzyme is allowed to pass through each reactor, that is 10 kg of the enzyme is already loaded in this, and then the moisture free IL at 60 to 70 degree Celsius is continuously pumped through these reactors at a rate of 1.5 to 2.5 kg IL per kg enzyme per hour, and the temperature and other conditions inside these reaction vessels are maintained by hot water circulation system at which that and the reaction is allowed to proceed, and at the end of the reaction there is a product pump where the material that is the catalyst is removed by using appropriate filtration and other methods, and then this interesterified IL is obtained. Then the next process is the winterization. In fact, winterization is a thermomechanical separation process where component triglycerides of fats and oils are crystallized from a melt or crystallized from a melt. The two component fractional crystallization is accomplished with partial solidification and separation of the higher melting triglyceride components. In this process, the fat is melted and heated to eliminate any crystal memory. The molten fat is cooled down under controlled agitation and cooling conditions to produce crystal nuclei formed by the higher melting triglyceride, and then the nuclei will grow to form crystals of the desired size. And when the crystallization has progressed far enough, the slurry is separated, and in fact this process allows to get, that is the winterization as well as tempering processes are allowed to get the fat of desired polymorphic conformations as well as desired characteristics for suitable in a particular process operations and so on. So, apparently this process looks very simple, but in practice this physical process is complicated by the fact that the formation of the nuclei depends upon foreign particles present in the aisle. So, aisle should have very good quality, the agitation, the temperature, the triglyceride composition and the type of the pre-treatment followed by the fat. So, the the crystallization actually occurs in two steps. One is, as I told you, the nucleation and then the crystal growth. Rate of nucleation depends upon the triglyceride composition of the aisle being winterized, the cooling rate of the aisle, the temperature of the nucleation and the mechanical power input or agitation. The crystal growth depends upon the crystallization temperature, time and mechanical input or agitation. Another important term here is the solvent fractionation. In fact, it is the term used to describe a process for the crystallization of a desired fraction from a mixture of triglyceride dissolved in a suitable solvent. Fractions may be selectively crystallized at different temperatures, after which the fractions are separated and the solvents are removed. Solvent fractions is practiced commercially, that is this solvent fractionation is practiced commercially to produce hard butters, specialty oils and some salad oils from which a wide array of edible oils. So, from these solvent fractionation, that is in fact different solvents can be used to fractionate different or specific triglyceride and then these specific triglyceride are further modified to have desired characteristic, desired properties to suit a particular food process operations. So, friend, so by now we have got I hope a good overview of the different processes by which different vegetable oils and fats can be modified to improve their functionalities, improve their usability in different food products and food processes and of course, improve their sensory, organoleptic and other characteristics. With this, I thank you for your patient hearing.